Hi statisticians, today's lesson is on grouping and experiments. Let's get started. Parents are worried that their kids spend too much time using a certain piece of technology that gives them access to addictive media content. Can you guess which technology? That's right. It's the radio. That's right, the radio. In fact, in this 1934 article from the New York Times, they observed that the radio seems to find parents more helpless than did the funnies, the automobile, and the movies. And they included a quote from Sidney Gruber, the director of the Child Study Association of America, who said, quote, "It is beyond dispute that many programs are objectionable because they convey false ideals or misleading sentimentalities, or because they murder the King's English, or play too recklessly with children's fears and horrors." A travesty indeed. But of course, it turns out that kids who grew up listening to the radio ended up becoming well-adjusted adults. However, that trajectory didn't stop those new adults from worrying about their children's access to another new invention, the television. In a letter to the editor published in the New York Times, this time from 1950, a concerned reader reported that grades were dropping among students who had TVs at home. They went on to say that, quote, "The statistics in themselves make it abundantly clear that television represents a new problem for the world of education, extending far beyond the classroom itself. Such a medium that can command such a high portion of children's waking hours is not merely a novel form of entertainment, it is a social force." And of course, it didn't stop here. The children who grew up on television then became adults who worried about their own children's exposure to arcades and video games. In 1982, you would have found in the New York Times this letter to the editor, where the author worried that video games were, quote, "cultivating a generation of mindless, ill-tempered adolescents." And finally today, the children who grew up on video games have become adults, now worried that their children's use of social media, and you don't have to look any further to find expressions of those worries. A quick Google search yields many results of articles voicing concerns about teenagers and smartphones, and particularly about the impact of social media on mental health. But unlike prior tech hysteria waves, this one is associated with some real and potentially concerning data. 2008 was a pivotal year for social media. The iPhone App Store and an early version of what is now the Google Play Store called Android Market both launched, and that meant that constant access to social media through smartphones started becoming more widespread in the years that followed. So, 2008 can be considered one of the last years before the social media boom, and we can look at different youth health metrics between that year and more recently. Specifically, we can look at the percent of U.S. individuals aged 12 to 17 who had major depressive episodes in the past year. And we can see that just before the social media boom in 2008, that rate was 8.2%. By 2024, it was 15.4%. That is nearly double. In 2008, 10.4% of U.S. university students had an anxiety disorder. By 2019, that rate was 24.3%. That is more than double. In 2008, 217.2 per 100,000 people in the 12 to 18 age group had visited an ER for self-harm. By 2023, it was 518.5 per 100,000. That's a lot more than double. Now, phones and social media are one thing that could explain these trends. However, since 2008, U.S. teens have also faced a global financial crisis in the Great Recession, a pandemic from COVID-19, and threats from climate catastrophe, and much more. How do we know that social media is truly the cause of declines in mental health rather than other potential factors? And trying to figure out this is our key question for today. Specifically, has social media caused declines in mental health? With that question in mind, let's move into our notes. We're going to cover 4 topics today, starting with completely randomized design. As we know, to answer a causal question, we need to do an experiment. And thankfully, many people are also asking the same questions that we are. There's a growing body of experimental studies on social media and youth mental health. Today, we're going to look at one of those studies, which took place at Iowa State University. At Iowa State, they recruited 230 student volunteers, and they had 2 treatments, asking students to limit their social media to 30 minutes per day, or asking them to use social media as usual. The student volunteers were randomly assigned to the normal use group or the limited time group. Then the researchers waited 2 weeks to see what would happen. When the Iowa State researchers ran the experiment, it turned out in psychological evaluations, the limited time group had significantly lower anxiety, depression, loneliness, fear of missing out, and negative mood. Note, when we say significantly, we mean that the differences were so large that they were unlikely to happen by chance alone. More on this later in the course. This study is an example of what we call a completely randomized design. Experimental units are assigned to treatments completely at random, with no pre-grouping. This is the simplest experimental design, analogous to a simple random sample in the sampling realm. Now, it's worth noting that there are other ways to set up experiments, one of which is called randomized block design. Imagine we only had 8 subjects, 4 in the normal use group and 4 in the time-limited group. The anxiety assessment scores are shown for both groups on the dot plots here. As you can see, after treatment, the limited time group, the group on the lower axis, tended to have a bit lower anxiety. But there's a lot of overlap. Many students from both groups had similar assessment scores, so it's hard to feel confident that the treatment had a substantial effect. Now, one thing that the Iowa State researchers pointed out in their paper was that female students tend to suffer from higher anxiety. So the researchers grouped the subjects, classifying them as female or not female. And we can see that both treatments, the non-female subjects tended to have lower anxiety in both treatment groups, and the female subjects tended to have higher anxiety levels. So by now comparing within those groups, the shifts in anxiety scores are easier to see. In other words, by comparing within groups and controlling for some of the initial variation between female and non-female students, the treatment effect is easier to detect. The Iowa State researchers used statistical models beyond what we learned in this stat course to compare the treatment effect within groups, female versus not female. So how could we do the same thing, but without using such models? Well, we can use what's called randomized block design, where experimental units are grouped in blocks based on an extraneous variable. Then, units are randomly assigned to treatment and compared within each block. This reduces extraneous variation, which allows for more precise comparisons of the response across treatments, and that makes the treatment effect easier to detect. To see an example, let's explore how Iowa State researchers could have used a randomized block design using gender for blocking. We'll begin by grouping our subjects into 2 blocks, female and not female. Again, once we have these blocks, we'll move on. Within each block, we'll number the subjects 1 to n sub b, where n sub b is the number of students in each block. Staying within each block, we'll put the numbers in on slips of paper and then put those papers into a hat. We'll mix them well, and this is how we'll randomize here. Note that shuffling slips of paper into a hat is just one of the randomization methods. We could have easily used computerized randomization, and that would work just as well. But for now, we're going to stick with the papers in the hats. In each block, we draw half of the numbers from the hat without replacement, and then the corresponding students are assigned to limit their social media time. The remaining students will continue to use social media normally. And here's the key part. After 2 weeks, we compare evaluations of anxiety within each group. This is the key step for a block design that makes its comparisons more precise, because effectively we're controlling for an initial variation of anxiety that already existed within the baseline group between the genders. And finally, we're going to combine or average those results to get an estimate of the overall treatment effect. Another type of experimental design is the matched pairs design. As we know, gender explains only a small part of the psychological factors that can vary a lot across individuals. So really, if we were to ask, who is the ideal control group for this sample of students, it turns out the answer is themselves. And this is exactly what a matched pairs design aims to do. A matched pairs design is a randomized block experiment in which either, first, each block is comprised of 2 similar experimental units, a matched pair, or the same experimental unit receives both treatments but in a randomized order. To see an example, let's explore how Iowa State researchers could have used a matched pairs design in their study. For each student, we would flip a coin. Heads would indicate that they would reduce social media use for the first 2 weeks and then use it normally for the next 2 weeks. Tails would indicate that they would use social media normally for the first 2 weeks and then reduce it for the next 2 weeks. Then, for each individual, we would find the difference between their anxiety evaluation scores after reducing social media and after using it normally. And then in this way, we're essentially setting up a whole bunch of little randomized blocks, with each student becoming a block being compared to themselves. And finally, we would find the mean of the differences to combine the results across our matched pairs. Now, we'll wrap up today by looking at the generalizability of these sorts of experiments. In the Iowa State social media experiment, students in the 30-minute per day group were expected to self-monitor their social media use. At the end of the experiment, they shared their phone data with researchers, but the researchers never enforced the 30-minute limit. Remarkably, even though the researchers did not enforce the restriction, there were still significant results in the treatment effect. To make sense of this, we want to know, can we generalize this result to all of the students at the school? Remember that the 230 students in the experiment were volunteers. Therefore, a potential problem here is the voluntary response bias. That is, compared to others, students willing to proactively volunteer to participate in a social media reduction study may be better at limiting their own social media use than others in the population who might not show interest in volunteering in such a study. In other words, these students might be different in their willingness to stick to treatment than other students at the school. So, when looking at the scope of conclusions for this study, we need to consider not just how the experiment was designed, but also how it recruited participants to be in the experiment in the first place. Since the treatment was randomly assigned, we can see a causal relationship. We know that among the students in the study, there is a causal effect from limiting social media. However, because the sample was volunteer-based rather than random, we can't necessarily generalize this result to the whole student population. We can only say that the treatment would likely create an effect among students similar to those studied. In particular, for students not similar to those studied, maybe those who are more attached to their social media accounts and those who are less willing to stick by the guidance, possibly it is that that treatment would not be as effective. This raises the question, to make our study more generalizable, why wouldn't the Iowa State researchers gather a random sample of all students on campus? Well, that's because it would be unethical and infeasible to force randomly chosen students to participate in the study. You can't force someone to sit for psychological evaluations, check in with researchers, share their phone data, and so on. For a study like this, you have to work with volunteers who give their consent to participate. So, finally, let's tackle our discussion for today. Because many psychological studies are done in universities, college students are often the subjects. If the same study we analyze today were conducted with high school students, do you believe that the treatment effect would be larger or smaller than the one we found at Iowa State? Why? Take a moment to jot down your initial thoughts to this question, and we'll discuss it further in class. That's it for today's Statisticians. We'll see you next time.